live.
Morning everyone, my name is Puri Sanjari, my partner is Shah Panji, but you can't see him because he's taking the video. Our project is called Patient Zero and has to do with bioinformatics. That means capturing data to help in the setting of perhaps hospitals. So what we did is we decided to create a really small device that will be able to capture certain interactions, more specifically the number of minutes or the number of seconds you spend with someone. Obviously, we didn't want to capture all interactions, so we had to fine-tune our adjustments or fine-tune our data to what range we get. So we thought the best way to actually accomplish this, something to be really low power and low cost, and at the same time have the capability to capture the necessary information. We decided to build a model of the Texas Instruments, and it's this little guy over here that you see. It's comprised of a microcontroller, an MSP430, and a radio frequency chip, CC2500. We originally wanted to add extra features, for example, SD card to be able to hold data, and accelerometer to be able to provide additional interesting information. So this actually board that we spent quite a lot of time designing using Eagle. The microcontroller part of it works in terms of controlling, for example, LEDs and whatnot, but we're having a little bit of issue with the radio frequency chip. It doesn't seem to be radiating. So we decided to do is revert back and use Texas Instruments as module, the one that we originally based it off and added extra features to. We had to change this a little bit, for example, add our own battery packs because we wanted to fit it on something perhaps this small that you will be able to wear on your wrist. I guess without wasting more time, I'm just going to show you the demo. If you come here close, you're going to see that we've been having these wristbands with these little modules on. Each are configured with a node. They're configured under my name, Puriya Shahab, and then I'm after our good TAs, Eric, Kunal, and Jeff. So what happens is when we plug them in, they start interacting and recording interactions. So I'm going to start plugging them one by one, and hopefully these batteries are still alive. And as soon as they come online, you should see them blinking. Now ideally we wouldn't want them to blink just to save power, but for the purpose of this demo, to actually show data is being exchanged, we are going to show some LEDs blinking. And obviously they don't want to come on now. Play around with it. That's strange. Okay, one is on. Two. I'm gonna add a third one just for the third one, and I'm gonna play around with a little bit this one, so hopefully it'll come on. As you can see, the other ones, and this one's online as well.
Oh, that's true. Yeah.
And they're going to start communicating. Now we've used something called the RSSI value to capture the range. We did a little bit of experiments with this. So you can see that whilst they're in range, everyone's going to be blinking and everyone's going to be talking with everyone. But for example, if you follow me, and we go a certain bit of distance away, you're going to see that this is going to stop blinking. It means it's no longer in range with the other nodes, which is potentially what we want because, well, it came on. We go a little bit further away. Has to do with fine adjustment. Again, we want to capture interactions within a certain range. So you're going to see that this LED is steady because we are more than 3.5 meters away from our other nodes. If you follow this, and as we approach closer and closer, you're going to see at some stage this LED is going to start blink. As it did, it went off and it came on. You're going to go on again, and we're in range and we're recording data again. And what happens is, we record the order in which we interact with each node and also the time with each node that we interact with. Finally, at the end of the day, for example, when we've captured enough data, what we do is we have a base station which comprises a similar structure, but its job is only to receive. So just for the purpose of reducing interruption, I'm going to move these other nodes, choose one, and come and send over its data to see what it's gathered during this time. Now, the hard part of this, a lot of the libraries are provided usually for these kind of stuff, but since we're working with the MSP430, it's a really small microcontroller, not too many libraries were produced or written for it, so we actually faced quite a bit of difficulties in actually finding ways to record the data, store it, and send it serially over to base station, and then from base station again transmit that to the computer. So there's several stages that we have to go through. So now, once we gathered this, I'm going to come over here to our base station. I'm going to transmit our data. You're going to see it's going to get serviced. The other home is blinking, and it's steady now. That means it's received all our data. And if you come here on the MATLAB, you're going to see that, well, it doesn't show it. I have to open a text file for you. It's opened. This node happened to be called Shahab, and if you open and analyze its context, you're going to see that it interacted for Puriya for about 125 seconds, with Jeff about 130, Kunal 95 seconds, and Eric 110 seconds. What we're going to do now is we're going to analyze the data for another node. And we're going to come again here, and we're going to see what data this guy has to produce. So again, I'm going to send my data, base station is going to process it, it's going to blink a couple times, and when it gets steady, it means it's not receiving data anymore. Now if you look at the computer here, you're going to see a new text file under Eric showed up. Again, for the purposes of just this, we're going to look at Eric. Shahab, Eric talked with Shahab for 155 seconds, with Puriya for 150, Jeff 175, and Kunal 140. Now, this is not very interesting. What's more interesting is when we actually get to visualize it and see what happened. So what I'm going to do is I'm going to show you a little script we wrote here. It's going to take all that information and do a really cool plot for you. What I have to do first is open up this script and give it the name of the text files that we want to analyze. In this case, well, first I have to shut down my base station. And I'm going to come here, and if you remember, they were called Shahab, right? And the other one was called Eric. .txt. I'm going to save this, and I'm going to run this script. Now this is where the cool part comes. One click of a button, and bam! We have this complex node structure here. But it's actually not very complex and easy to follow. Remember, we analyzed Eric's and Shahab's text files, so we have to look at their nodes and see where they radiate. So if you come closer to me, you're going to see that Eric, in this really cool plot, connected with Puriya, connected with Jeff, and connected with Kunal, and also connected with Shahab. Now, if you notice very carefully, the colors are somewhat different. They indicate the time that you were in contact with each other node. Now, the whole story of the interactions will be told when we analyze the text files from the other three nodes as well. You're going to see a similar webbed structure, or it's a webbed node, webbed graph rather, being produced. But the sole purpose of this, you can see that, again, Shahab talks with everyone, Eric talks with everyone. This is, because we started off at the same place and then we kind of diverged. So everyone's going to have a connection with this. Now let's see, this doesn't tell us the order with which we connected in. But we've written actually another script that you analyze it. And we're going to come here and you're going to say, if I remember the code correctly, it was connection, order, and we're going to run it. And it's going to ask us, which node do you want to analyze? And we're going to say, we want to analyze Shahab. How do you spell Shahab? Enter. And we go back to our node, you're going to see this web now has connection 1, connection 2, connection 3, connection 1. That means Shahab actually talked with me first, with Puriya first, and then talked with Jeff, and then talked with Kunal, and then finally met Eric. And now, obviously, this data, will be supplemented with many other stuff, but it's the basis, it's the start ground where you actually can track, for example, in a hospital setting, patient-doctor interactions. And from that, for our purposes, which we were interested in actually solving, is in case a disease outbreaks and you localize or you find out which patient is the carrier of disease, you can look at its note and see who he's been in contact with and quickly quarantine them because they might be potentially carriers of that disease. And we hope you enjoyed the demo, and that's about it. Thank you.